Assalamualaikum warahmatullahi wabarakatuh, and a very good morning to everyone, especially to my lecturer, which is Dr. Nur Hasliza. My name is Nur Balkis binti Muhammad Marwan from BM2. So today I want to make a presentation to fulfill my fourth assignment in MTES3352 in Introduction to Mathematics Reasoning. So I want to present about the solve one regular and one semi-regular solid non-routine problem. So, based on the tasks that given by the lecturer, of course, the first thing that we have to know is what the meaning of the non-routine problem. So I can explain in this presentation. A non-routine problem is a complex or unfamiliar situation that requires critical thinking, creativity, problem solving, skill to resolve. Non-routine problems often transcend the boundaries of conventional thinking, demanding innovative approach and a willingness to explore uncharted territories. Non-routine are the problems that replicate real-life situations and do not provide keywords to solve using known procedures or standard methods. It is based on the words that say by Arslan Al-Attar. These problems typically do not have a straightforward solution and may involve multiple steps, various strategies, and often require the application of knowledge in novel ways. Moreover, they often demand creativity and critical thinking to devise effective approaches. In tackling such complex issues, it is essential to embrace ambiguity and be open to exploring diverse perspectives. This not only foster innovation but also cultivates resilience and overcoming obstacles. What is a regular solid non-routine problem? Regular solids are three-dimensional polygons whose sides are all of equal lengths and whose angles are all equal. The other name of a regular solid is a platonic solid. Most people call the regular solid with the name platonic solid. There are 5 types of regular solids, which is tetrahedron, cubes, octahedrons, dodecahedrons, and icosahedrons. Each solid has its own unique properties and similarities, making them foundational elements in the understanding of geometry and mathematics. Beyond their mathematics importance, platonic solids have also been associated with metaphysical and symbolic meanings through history, reflecting their enduring fascination and relevance across various disciplines. So, the question about regular solids that I want to present today is: a group of architects is designing 2 units building is represented by a cube. As they finalize their design, they notice an interesting relationship between the 2 structures. The ratio of the lengths of the edges of the first cube to the second cube is 3:5. 3/5. As they delve deeper into their calculation, they discover that the volume of first building is exactly 729 cubic meters. Integrate, they set out to determine the volume of the second building. In their pursuit of architectural excellence, they realize that the second building's volume is crucial for their plans to harmonize the design. Find the volume of the second building. The first thing when we get the question, we have to make a step. In this question, the first step is we have to find the multiplication factor based on the ratio, which is 3/5, and the real volume of the first building. So, based on this step, we have to find the multiplication factors. Then, we have to use the multiplication factor to find the volume of the second building. So, we can look at the slide that in my background. In this question, we have the information that's given, which is the ratio of edges of 2 cubes is 3/5. Let's 3x and 5x be the edges of cubes. And we know that the volume of cube, if we took the cube named A, and the volume of this cube will be A cube. So we need to find the volume of the first cube, which is 3x cube, and it's equal to 27 cube, and then 27x cube equal to 729 meter squared by 3. So we have to divide 729 divide by 27. So when we got the answer, which is the 27, which means x squared by 3 equal to 27. Then we can find the x, which is we can make the 27 square root by 3. So it will equal to 3. So here, the edges of the first cube equal to 3x, and we substitute the number of 3 into this x, which means 3 multiplied 3 equal to 9. Then the edges of the second cube, which is 5x, we substitute 3 into this x, and it's equal to 5. It multiplied 3 equal to 15. So based on this information, we can find the volume of the second cube, which is 15 squared by 3, and this will equal to 375 meters cube. Then we move to semi-regular solids non-routine problem. What is a semi-regular solid? A semi-regular polyhedron is called Archimedean solid. Archimedean solid feature a combination of regular polygons meeting at each vertex. These are three-dimensional shapes composed of flat face, straight edges, and vertical corners. Examples of Archimedean solid include the truncated cube, truncated dodecahedron, cubotahedron, and a rhombic-cubotahedron, and among others. So, in this slide, we have a semi-regular solid equations. What is the equations? Okay, I read. An Archimedean solid called snap cube, which is figure 7, has 32 triangular faces and 6 square faces, as well as 24 vertices. Calculates how many edges it has and find the edges length if the total surface of the snap cube is 470 square and the height of triangle is 4 cm. In this equation, it has 3 main steps, which is the first one, we have to calculate the number of edges, which is E of the snap cube, using Euler formula. Then, we have to substitute the value of E and F in the Euler formula. The third one is substitute the number of height of triangle value and the total surface of snap cube. Then we can get the answer. So what is the solution of this equation? The first one is we have to list the information that given in the equation. So here, the number of triangular faces is 32 and the number of square faces is 6, while number of vertices is 24. So, to calculate the number of edges, E, of the snap cube, we will use Euler's formula for polyhedra, which is V minus E plus F equal to 2. First, we need to find the total number of faces, which is F, by adding the number of triangular faces and the number of square faces, which means F equal to 32, which is a number of triangular faces, plus 6, which is a number of square faces. So the F is equal to 38. Now we substitute the value of V and F in the Euler's formula and solve for E, which is 24 minus E plus 38 equal to 2. So here 24 plus 38, we will get 62 minus E equal to 2. So here minus E equal to minus 60 and E equal to 60. So here we can get the answer of the snake cube, which is snake cube has 60 edges. Then we have to find the length of the edges. The length of the triangular and the square is same. So based on the formula that we know of the triangle and a square, so we have to make an equation, which is 32 multiple 1 per 2 multiple y multiple 4, which is the height of triangular, and then plus 6 multiple y equal to 470. After we make a calculation, then we get the 64y plus 6y squared equal to 470. Then we get the quadratic equation, which is 6y squared plus 64y minus 470 equal to 0. So when we calculate this quadratic equation, we will get y minus 5 multiple 3y plus 47 equal to 0. So here we will get the answer, which is y equal to 5 and y equal to negative 3 per 47. So based on this answer, we know that y equal to negative 3 per 47 is not valid. So we get the answer, which is y equal to 5. After that, we move to relationship that exists in for regular and semi-regular solid non-routine problem solving. Non-routine problem solving involving regular and semi-regular solid often delves into their unique properties and characteristics. So here are some relationships and concepts that can be explored in such problem-solving scenarios. The first one is vertex configurations. Regular solids have a uniform vertex configurations, meaning the same number of edges meet of each vertex. For example, in a cube, 3 edges meet at each vertex. Regular solids have a uniform vertex configurations. Semi-regular solids also have consistent vertex configurations, so they may vary across different vertices within the same solids. Identify and analysis this configuration can be crucial in a problem-solving scenarios. Then, the second one is symmetry. Regular solid exhibits high degrees of symmetry. Each face, edges, and vertex is equivalent in terms of its positionings and orientations. This symmetry can be exploited to solve problems involving transformation, such as rotation and reflection. Semi-regular solid possess symmetry as well, so it may not be as uniform as in a regular solid. The third one is edge-length ratio. In the regular solids, all edges are congruent, leading to consistent edge-length ratio throughout the solids. Semi-regular solids may have different edges lengths due to the variation in face shapes. Analyzing the ratio of edges length and their implication for the overall structure can be non-routine problem challenge.
So this all the reference that I used to make a presentation.
I think that's all my presentation about regular solid and non-regular solid in non-routine problem solving and the relationship between them. So I think that's all from me. Thank you.